My name is Dr. Matthew Swabey. I'm the director of the Bechtel Innovation Design Center here on Purdue. 3D printing is in some ways very similar to traditional printing. In traditional printing, we take ink and press it onto a page to make a picture. In 3D printing, we take whatever material it is, traditionally plastic, and we print it into the shape that we want. Another way of looking at it is traditional manufacturing tends to start with a block of something, like a sculptor has a large block of stone, and then chisels and removes material around, leaving behind the statue. We call that subtractive machining. This is additive, where we take material and add it to the space that it's going to occupy. 3D printing has a couple of really key advantages over traditional manufacturing. From the one hand, it is perfectly possible to make shapes that are almost impossible to create using normal methods. If you look at either of these, you can see that they have a lot of structures inside them. In normal subtractive manufacturing, I would have to drill or cut or attempt to form the shapes inside. And that's just simply not possible with these shapes. Because in 3D printing, we're creating shapes kind of in space, we can add internal structures. You can create nests of pipework. You can create all sorts of interesting things that are almost impossible to make. Another example is this, where it's a bracelet made out of printed metal, but the hinges and so on were all printed while it was being made. It never was a collection of separate pieces that needed to be put together. It was printed as it is right now. Right now, 3D printing has a couple of big limits. One of them is the physical size of the machine you have. So being able to print into a space is tricky because that space has to be a space the printer can move in. There are some modern technologies around where companies are even 3D printing homes, where you have a big rig moving. But the better the detail that you need, generally speaking, the smaller the printer you have, the smaller the object you can make. Because any kind of flexing or motion of the printer when it's building will reduce the accuracy of the item. 3D printing has already, in some ways, taken over certain high-end types of manufacturing. So, for example, fuel nozzles and gas nozzles for jet aircraft, turbine blades, and so on. Many of these are produced by 3D printing right now, commercially. It, at the moment, occupies a niche for very expensive, low-volume things as well. A traditional machining strategy would often involve creating a lot of things around what you want to make it easier to hold, to work with it. Whereas the 3D printing works off a program. If you want 100 slightly different items, the 3D printer will produce those just as quickly as the first item. Whereas modern manufacturing is typically more set up for productions of lots of identical things. I think the future of 3D printing is very bright still. There are a lot of advantages for traditional manufacturing, but many of them are because we've used it for hundreds and hundreds of years. This technology isn't brand new, but it's still in its infancy compared to any of the other strategies we use to make things, joining sheets together. I mentioned the sculpting example where we take away material from a block, leaving behind what we want. This whole idea of just creating it from nothing in the space that it's going to be in, I think has a lot of possibilities to continue to displace more and more traditional methods. We're already starting to see some of it in terms of custom clothing and footwear items. I myself used the Invisalign teeth straightening technology. That was 3D printed. The mouth guards are 3D printed. So personalized, to me specifically, items can be produced at effective prices and used to make everyone's lives better. So there's many areas where this is already very practical and in use, and I only see those examples grow. 3D printing has a massive value in both education and when you're exploring an idea or concept. It is so much cheaper to do the design and then do the print than it is to manually manufacture a concept or idea. A key advantage of 3D printing, in many ways, is when the printer's running, you can be moving on with the next stage of your design. Whereas in subtractive machining, typically someone has to be hands-on with a lot of it, even with automated manufacturing. There's a lot of kind of in-person work, especially for the smaller ones, smaller volume productions like prototypes.